Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Tutorial, Part 13. So in this video we will discuss about data frame in details Part 2, as you can see here all these 12 things we will going to discuss. So let's get started. First we will discuss about dropping. Another operation that is connected to index objects is dropping. Deleting a row or a column becomes simple, precisely due to the labels used to indicate the indexes and column names. Also in this case, pandas provides a specific function for this operation, drop. This method will return a new object without the items that you want to delete. For example, take the case where we want to remove a single item from a series. To do this, define generic series 4 elements with 4 distinct labels. Let's see the example. Now, for example, you want to delete the item corresponding to the label yellow. Simply specify the label as an argument of the function drop, to delete it. Now you can see here we got only 3 elements, cause yellow elements is deleted. To remove more items, just pass an array with the corresponding labels. As you can see here. Regarding the data frame, instead, the values can be deleted by referring to the labels of both axes. Declare the following frame by way of example. Now you can see here, this is the original frame, and this is the after deleting. To delete columns, you always need to specify the indexes of the columns, but you must specify the axis from which to delete the elements, and this can be done using the axis option. So to refer to the column names you should specify axis equals 1. As you can see here already deleted 2 columns. Now we will discuss about arithmetic and data alignment. Perhaps the most powerful feature involving the indexes in a data structure is that pandas is able to perform the alignment of the indexes coming from 2 different data structures. This is especially true when you are performing an arithmetic operation between them. In fact, during these operations, not only may the indexes between the 2 structures be in a different order, but they also may be present in only one of the 2 structures. As you can see from the examples that follow, pandas proves to be very powerful in the alignment of the indexes during these operations. For example, you can start considering 2 series in which they are defined, respectively, 2 arrays of labels, not perfectly matching each other. Now among the various arithmetic operations, consider the simple sum. As you can see from the 2 series just declared, some labels are present in both, while other labels are present only in one of the 2. Well, when the labels are present in both operators, their values will be added, while in the opposite case, they will also be shown in the result, new series, but with the value nan. Alright, now see here, the black is nan. Because black doesn't have in the series 1. And similarly brown and green are same. In the case of the data frame, although it may appear more complex, the alignment follows the same principle, but is carried out both for the rows and for the columns. As you can see here we declared two frame. And here we got same result in same way. As you can see before. Now see here we got blue ball 6.0. That means, from here we got 4, plus here we got 2 equal to 6. And similar way rest of the element are calculated. Now we will discuss about flexible arithmetic methods. You've just seen how to use mathematical operators directly on the pandas data structures. The same operations can also be performed using appropriate methods, called flexible arithmetic methods. In order to call these functions, you'll need to use a specification different than what you're used to dealing with mathematical operators. For example, instead of writing a sum between two data frame 1 plus frame 2, you'll have to use the following format. As you can see, the results are the same as what you'd get using the addition operator plus. You can also note that if the indexes and column names differ greatly from one series to another, you'll find yourself with a new data frame full of NaN values. You'll see later in this chapter how to handle this kind of data. Now we will know about operations between data frame and series. Coming back to the arithmetic operators, pandas allows you to make transactions even between different structures, as for example, a data frame and a series. For example, we define these two structures in the following way. Now you can see the output. The two newly defined data structures have been created specifically so that the indexes of series match with the names of the columns of the data frame. This way, you can apply a direct operation. Now you can see here we got first rows every columns is 0, after subtract. As you can see, the elements of the series are subtracted from the values of the data frame corresponding to the same index on the column. The value is subtracted for all values of the column, regardless of their index. If an index is not present in one of the two data structures, the result will be a new column with that index, only that all its elements will be nan. As you can see here we add new column as mug. And after subtract we got nan in all the row of mug column. Now we will know about function application and mapping. The pandas library is built on the foundations of NumPy, and then extends many of its features, adapting them to new data structures as series and data frame. Among these are the universal functions, called ufunc. This class of functions is particular because it operates by element in the data structure. As you can see here, square root. Now we will know about function application and mapping. Functions by row or column. The application of the functions is not limited to the universal function functions, but also includes those defined by the user. The important thing is that they operate on a one-dimensional array, giving a single number for result. For example, we can define a lambda function that calculates the range covered by the elements in an array. Using the apply function, you can apply the function just defined on the data frame. Let's see here. As you can see here, the last row contains max value, and first row contains min value. Now see here, after subtract max and min, every column value is 12. The result, however, this time it is only one value for the column, but if you prefer to apply the function by row instead of by column, you have to specify the axis option set to 1. Now you can see here we got 3 as every row's value. As you can see here, this column contains minimum value, and this column contains maximum value. After subtract, we got 3 as every row's value. It is not mandatory that the method apply returns a scalar value. It can also return a series. A useful case would be to extend the application to many functions simultaneously. In this case, we will have 2 or more values for each feature applied. This can be done by defining a function in the following manner. Then, apply the function as before. But in this case, as an object returned, you get a data frame and no longer a series, in which there will be as many rows as the values returned by the function. Now you can see here we got only 2 rows, the first rows contains minimum value, and the second rows contains maximum value. Now we will discuss about statistic function. However, the majority of the statistical functions for arrays are still valid for data frame, so the use of the apply function is no longer necessary. For example, functions such as sum and mean can calculate the sum and the average, respectively, of the elements contained within a data frame. Now you can see here, we got sum of every columns. And see again, here we got average of every columns. And there is also a function called describe, that allows to obtain a summary statistics at once. Now you can see here, we got different kind of function at a glance. Now we will know about sorting and ranking. Now see here index are alphabetically arranged. As you can see, the items were sorted in the alphabetical order of the labels in ascending order, from A to Z. This is the default behavior, but you can set the opposite order, using the ascending option set to false. Now you can see here, index are arranged according to alphabetically descending order. As regards the data frame, the sorting can be performed independently on each of its two axes. So if you want to order by row following the indexes, just continue to use the function sort_index, without arguments as you've seen before, or if you prefer to order by columns, you will need to use the axis option set to 1. Now here we declared a frame. Now see here, first one is original frame. And second one is frame with sort index. And third one is sort index with axis 1. Now we will know about correlation and covariance. Two important statistical calculations are correlation and covariance, expressed in pandas by the CORR and COV functions. These kind of calculations normally involve two series. So now here we declared two series. Now you can see here we got correlation and covariance. Actually these two things we discussed in details in NumPy tutorial previously. You can watch the NumPy tutorial. Now we will know about NaN data. During the previous sections we have seen how easily the missing data can be formed. They are recognizable within the data structures with the value NaN, not a number. So, having values that are not defined in a data structure is a condition quite common for those who carry out data analysis. However, pandas is designed to better manage this eventuality. In fact, in this section you will learn how to treat these values so that many issues can be obviated. In fact, for example, within the pandas library, the calculation of descriptive statistics excludes NaN values implicitly. So first of all, we will know about how to assigning a NaN value. Just in case you would like to specifically assign a NaN value to an element in a data structure, you can use the value np.nan, or np.nan, of the NumPy library. Now here you can see the NaN value, after assigned. Now we will know about how to filtering out NaN values. There are various options to eliminate the NaN values during the data analysis. However, the elimination by hand, element by element, can be very tedious and risky, because you never get the certainty of having eliminated all the NaN values. The drawna function comes to your aid. Now you can see here, after using the drop NA function we got output without NaN values. Another possibility is to directly perform the filtering function by placing the not null in the selection condition. Now you can see, here we got output without NaN value in another way. If you're dealing with the data frame it gets a little more complex. If you use the drawna function on this type of object, it is sufficient that there is only one value NaN on a column or a row to eliminate it completely. As you can see here we got empty data frame, because NaN value is eliminated completely. Therefore, to avoid having entire rows and columns disappear completely, you should specify the how option, assigning a value of all to it, in order to inform the drawna function to delete only the rows or columns in which all elements are nan. Now you can see here we got 2 rows because middle of the rows is totally nan. Now we will know about filling in nan occurrences. Rather than filter nan values within data structures, with the risk of discarding them along with values that could be relevant in the context of data analysis, you could replace them with other numbers. For most purposes, the fillna function could be a great choice. This method takes one argument, the value with which to replace any nan. It can be the same for all, as in the following case. Let's see here, as you can see here we got 0.0 instead of nan value, because fill na function is replaced nan to 0. Or you can replace nan with different values depending on the column, specifying one by one the indexes and the associated value. As you can see here we got different values instead of nan values. Alright, friends, our today's video was up to this. Thanks for watching the video. See you in the next video. Please subscribe our channel and don't forget to like and share the video. Thank you.